a venture scientist is kind of the opposite end of the spectrum to a pure research scientist. So pure research scientist gets the opportunity to look at blue skies research and ask some of the deepest questions in the universe. A venture scientist sits at the other end and is responsible for actively translating breakthroughs into something useful in the marketplace.
Hello, everyone. My name is Vinay. I lead investor partnerships for EMEA at Tracxn. Thank you for joining my interview series, The Sourcing Stack. Through this interview, I speak with leading venture capitalists and operators to understand how venture capital is evolving and where the next generation of transformative companies will come from. Today, I am delighted to be joined by Ben Miles, co-founder of Empirical Ventures, a specialist deep tech fund and venture builder backing some of the most ambitious scientific founders across Europe. Dr. Ben brings a unique perspective at the intersection of science and entrepreneurship and capital. He began his career as a physicist before moving into the world of venture building and investing, with a strong focus on helping scientists translate breakthrough research into real-world companies. Through his work with Spin-Up Science, he has supported hundreds of spin-outs and trained thousands of PhD researchers to think like founders. At Empirical Ventures, Ben and the team are building a platform designed to take ideas from first principles, working closely with scientists to turn fundamental research into venture scale businesses across areas like life sciences, quantum computing, advanced materials, and robotics. Along with this, Ben is also widely known for his work in communicating complex scientific breakthroughs to a global audience, helping bridge the gap between cutting-edge research and public understanding. Ben, it's great to have you with us today.
Awesome. Great to be here. Thank you so much for having me.
Great. Let's start the podcast with the origin story and mission. Empirical Ventures was built around a clear idea that scientists should become entrepreneurs. What did you see broken in the traditional system that led you to build this fund?
So that requires me going back a few steps, and it's kind of like my origin story at the same time. So I came out of the PhD to find very few jobs for scientists outside of academia and industry actually existing. I got very lucky with the experience that I had, involved in a very small startup, a spin out from the university. And even they really struggled to find capital that was capable of understanding the language which we were trying to describe our technology in. We were saying words to investors like synthetic lectin. And so often we would watch across the table as people's eyes would kind of roll back in their head and they would say, can't you just, be the next Facebook for X or the Uber for Y or any of these sorts of things? That into my venture building career was a point of just resonance. We found it really difficult with the investment community to find groups that could look at science that had just come out of academic institutions and universities and get to conviction to the point where they could say, yes, this is worth writing the first ticket into. That was our frustration from that side. And so that was what we wanted to solve. We wanted to be a team of PhD scientists that were commercially literate and experienced as operators and entrepreneurs that could look at the very earliest science, de-risk it to make sure the rest of the market, the rest of the investor market could participate in those sorts of things. Because that's where we see one of the main sticking points of actually getting technologies out the door of universities is who provides the first ticket into them.
Great. Thank you so much for outlining that very clearly. Now, you've spent years working with scientists through Spin-Up Science before launching Empirical. What were the biggest gaps you saw in how research gets translated into companies?
I think the biggest gap why I started that company is because very few people go into a PhD thinking at the end of it, they're going to be an entrepreneur. You think broadly, I will go into academia, publishing, patenting, or maybe homelessness. That's pretty much your range of options. I thought and was increasingly kind of frustrated at the rate of us taking groundbreaking technology and actually doing anything with it. And one of the main bottlenecks is that we were typically waiting for a been there, done it before entrepreneur with a bit of gray hair to pick up these ideas and help the university commercialize them. And at the same time, I was seeing my peer group, PhD scientists, struggle to find jobs. And I was like, these two problems mutually solve each other, right? If I can create an aspiration to entrepreneurship and give people the fundamental kind of commercial skill set that lets them get going, I can create a pipeline where we're taking ideas that otherwise would sit in a journal for the rest of their lives and actually turn them into something that will help society and potentially the world. So that was the kind of crowning ethos of Spin Up Science. Just how do I raise the visibility of entrepreneurship, and how do I empower a generation of scientists to realize that not only are they capable of doing it, but also like that is their job.
Right. You've been working closely with scientists even before Empirical through Spin Up Science. So you've seen this from the inside, like. Great. Now, you often talk about venture scientists. What does that mean in practice, and how it is different from traditional founder, from a traditional founder?
Yeah, great question. So a venture scientist is kind of the opposite end of the spectrum to a pure research scientist. So pure research scientist gets the opportunity to look at blue skies research and ask some of the deepest questions in the universe. A venture scientist sits at the other end and is responsible for actively translating breakthroughs into something useful in the marketplace. So they have all of the technical skill set, but they are complemented by a set of commercial understanding and entrepreneurial spirit and a refusal to be told no too many times, and become this really interesting activated player in the ecosystem. I think one of the main reasons that we're so bad at translating science is because at the end of an academic output, so like a Nature paper or a science paper, our technologies are typically sitting at TRL3. So they're interesting, but they're kind of proof of concept. They're really rough around the edges. And actually we produce so many of them that it is absolutely hopeless, the idea, which is what most scientists are told, that we could pick them up and throw them over the fence and industry groups would grab them and run with them. That like fundamentally doesn't happen at the volume that we would need it to, because it's expensive and there's a lot of them. So industry groups just broadly say no. So really like what the goal of a spin out is to be a TRL acceleration engine, to get from TRL3 to TRL6, 7, maybe 8, 9, but to make sure that it is easier to commercialize. And that's exactly the role of a lightweight, fast moving entrepreneurial team. So that's interesting because it's created a role model that we haven't really had the opportunity to have before, which is PhD scientists participating as entrepreneurs in this ecosystem, which I think is a really cool opportunity.
Great. That's a really interesting way to frame it. Now, moving on to the next section, like venture builder versus a traditional VC, right? Empirical is not just investing, but actively building companies from first principles. Why did you choose a venture builder model instead of a traditional VC approach?
I think I'd have to guiltily admit that I sit on the entrepreneur end of the spectrum as much as the investor end of the spectrum. So in part, it's because it scratches an itch of my need to just build. What I also saw in the market is that it's reasonably rare that you have very experienced operators and entrepreneurs running venture capital funds. And oftentimes the advice that I was hearing in the boardroom sounded broadly sophisticated, but for teeny tiny lightweight teams, actually was more cumbersome than useful. So I was really interested in, can I sit as someone that is entrepreneurially aligned, the kind of co-founding guardian angel around these sorts of early academic teams, and provide them the commercial backbone that as they upskill kind of complements the technical skill set and the breakthrough that they're commercializing. I really believe that scientists are very quick at upskilling into MBA level knowledge, but they really benefit from kind of proximity and surface area to someone that's just been there and done it before. So that gives us like the building element of it, and then the powerful piece and the kind of understood mechanism of VC investment kind of sweetens that to make sure those ideas are fundamentally coming out of the universities. And that's really what we focus on. Like, why are we getting such a capping of the bottle in that ideas don't really translate or even get started so often?
Right. That's actually really an important distinction, I would say. Now, moving on to the next one. At the early stage, how do you go from scientific discovery, venture backable company, scientific discovery to a venture backable company?
So is that a venture building assembly question? What does that actually mean? So I think there's like 5 points to that.
Mm-hmm.
Usually when I start working with teams, they've had some fundamental discovery that's got them into an interesting publication of merit, like a Nature journal or Science journal or something like that. To actually get them out the door, there are 5 things that then need to happen. You need to coalesce a team of co-founders. I prefer significantly to pull from the academic team, the PhDs and postdocs that are part of that discovery. There's an option to pull from the senior academics, the PIs, the professors, but oftentimes they're embedded in the university and they're running big academic groups. So I don't mind if they sit internal to the university, but I want some entrepreneurial firepower that's got some legs to it. You care about, which can be a slightly controversial point, how do you access the intellectual property out of the university and on what terms? Because although these scientists will have invented their idea, it is the university that becomes the owner of any intellectual property that they've created, and there becomes a really awkward bargaining exchange as to how you re-ask for the idea that you invented back off of your academic institution to then be allowed to turn it into a company. That is a whole conversation in and of itself, which maybe we'll get to. Then you care about building out the commercial plan, which is what you'd imagine, the entrepreneurial kind of activity, planning out, 5 years in good detail, next 5 years beyond that in rough hand waving detail. Then you start raising investment, and typically you're going to early stage venture capital and grants to get those companies up and off the ground. And then finally, you look for somewhere to work. And that actually is a non-trivial activity, because most academics, most universities, most institutions still view the model as my spin-out company that I create can just keep working in the lab space that they were working in when they were an academic team.
Right.
Which creates a bit of conflict, both of culture, of we want to get academics moving from research academic speed to entrepreneurial academic speed, but also in terms of just the expense of the equipment around them. Universities are unbelievable places to do science discovery because they're well protected from the kind of market winds. The downside of that is that they have infrastructure that is more expensive than typically a startup would choose to pay for. So we like finding ways of building, and one of the first ventures that I supported when I was sitting in Xylo, the other company, so I was spread across 2 companies at once, was a group working out of Bristol called UnitDX at the time, now called Science Creates, that were just building bespoke lab infrastructure because it's so difficult to actually find as a scientist. It was one of the reasons that our company almost failed, that we were going to have to move out of the city of Bristol near the academic institution that we needed to be in and just hope to find some other infrastructure space. And in all honesty, there isn't that much going around. Even in the places that you look for, like the Oxford, Cambridge, Londons over in Silicon Valley, it's still reasonably rare that you find a place that you can do complicated wet lab chemistry in. So you need to find that, and you need to find it early. All those 5 things, they all take about 9 months to sort. So my preference is that you do them in parallel, and that's kind of what we help with, rather than you do them in serial, because otherwise that journey becomes a very long journey. That's broadly what I look at.
Great. I mean, that's a really long journey. Now, many deep tech ideas are technically brilliant, but commercially unclear. How do you assess whether a piece of research can actually become a scalable business?
Yeah, it's a great question. So what we're operating in is traditionally not what most business-minded individuals approach ideas from. Typically, they're looking at market pull opportunities, right? They're saying, what is the problem in the market that I can find, and how do I go out and just find the best solution to actually solving it? Here, we're approaching it from the reverse direction. We, through blue skies research or applied research, have developed an invention that seems to have some utility, but it's very rare that it's a perfect map to a particular problem space. So a lot of the initial area that we work around, this space is called tech push as a kind of like approach, is about application mapping. And what I have found is that some of the most interesting applications actually are outside of the core field. Like, how do I take an invention in fusion and use it to improve the creation of medical isotopes? How do I take an improvement in quantum algorithms and sensing and use it to detect really low levels of CO2 and methane? So outside of the sphere that these technologies were actually maybe invented for, you suddenly find if you're moving into those spaces, one, that the marketplace already exists and hopefully that it is large, and two, that you're much more likely to have an order of magnitude improvement over existing solutions. And that's when you find yourself in a really interesting space. So that's just a category of deep tech push opportunities, but it's one that we look at really closely because it de-risks the market complexity. Because in deep tech, you have higher just technology stack risk. So there's a nice kind of balancing effect there. It doesn't mean that you don't also do new markets with new technology, but there's like an interesting kind of sweet spot of like what that asset class can deliver there that just becomes, like I said, order of magnitude better than what anyone in the market expected to suddenly start coming to market.
Right, that's an excellent answer, I must say. Now, deep tech is an area of focus. You focus on areas like life sciences, advanced materials, quantum, robotics, and tech bio. Which of these are you most excited about right now, and why?
So I usually come back one step and I say, if it's science, I'm interested in it. So deep tech to me is breakthroughs in fundamental physics, biology, and chemistry. And I think where I find it most interesting at the moment and where we kind of specialize, really like deep tech as an asset class is kind of early. We're 5, maybe 10 years into the process of like understanding how do we look at these sorts of technologies? When is it viable to start commercializing them? When is too early? When is too late? So the bit I find really interesting isn't necessarily a sector at the moment. It's like a stage. And it's that sweet spot as it is coming out of academic institutions to understand, would 2 years more cooking within academia actually move the needle significantly further? Or have we already missed the mark? And we need to get moving as soon as possible, right? There was suddenly a ton of academic groups during the pandemic that were like turning their attention to what are interesting ways to do vaccine development. Well, that's interesting, but it's going to be several years of academic work and then several further years of commercial work. So you're already aligning yourself to something that maybe misses the mark of the opportunity. There are a lot of opportunities also that kind of point in the reverse direction, where academia doesn't realize that it is 10 years ahead of what industry can do. And it's presenting it still as academic curiosity and scientific interest, and actually commercializing those things would be really powerful.
Great. Now, we are seeing increasing hype cycles in deep tech, especially around AI and quantum. How do you separate real breakthroughs from noise?
So that is, yeah, it's a great question. That is, I think, again, kind of points back to we've only really understand the commercialization of science very recently. Back in the day, the guy that was inventing the telescope was also applying the telescope to do something useful with it. We've gone through, since the Industrial Revolution, I'd say, we've gone through a long period of time where actually fundamental scientific discovery has had a really long time frame between when it occurs and when it becomes useful. Very recently, we've become much better at understanding what that time frame is. And when it falls on venture-backed time frames, so like about 10 years, preferably less than 10 years, that's when it enters into deep tech, right? So deep tech is actually a band of how long does it take to commercialize a breakthrough idea. And below the deep tech band, I refer to it as mythic tech. It's cool, it's interesting. It might one day be useful. Think like fusion. Back in the day, I mean, you'd even said stuff like CRISPR, right? Like, wow, this is amazing. CRISPR took like 10 or 11 years to go from first discovery to how do we like reliably implement this into something useful and generate a reliable set of assets that come out of it that use it as a backbone. So deep tech is that wedge that becomes interesting. And I think where things fall, long-winded answer to get back to hype cycle. I think where things fall in terms of misunderstanding and hype cycle is often when we are just misunderstanding the time frame over which we can evolve these ideas. AI is very different. It's at the top. It's kind of like between deep tech and shallow tech. Sorry, all the tech guys, software is shallow tech now. But quantum still sits at the boundary between mythic tech and deep tech. And the bits that are crossing that more quickly are exactly the sort of opportunities that I described. I call them quantum adjacent. So how do I take a quantum algorithm and look for CO2 or methane better than anyone else? Those things suddenly become commercializable in realistic timeframes. And when you say quantum is hype, I mean, it's fundamentally not. Like there are products in the market solving things, right? LEDs are based on a quantum effect. Quantum isn't hype. Quantum computing maybe is a specific piece of quantum. We haven't seen the deliverable on that. Same, we haven't seen the deliverable on fusion yet. But these are kind of like matter of time scale kind of problems. And it's really difficult to predict until you've done it the first time. How long does a new idea take to evolve through that process? That's kind of where we are in terms of whether things are hype or not. We're still kind of learning, but I think it's a matter of time.
Yeah, agreed. I mean, that's a very interesting way to frame it. Now, looking at your portfolio, many companies are solving very fundamental problems. How do you balance long timelines with the expectations of venture returns?
Absolutely. So I would say that is just a intrinsic problem with deep tech. We're trying to do very big, very meaningful activities. We're trying to save lives. We're trying to change how the planet uses energy. But you need to balance that against the whole model of venture, obviously, is we raise capital and we deploy capital and we look for a return. And that return timeline is kind of based on how patient people are. And like I said, it's a roughly 10 plus 2 is what the world has decided is kind of acceptable, because I guess people want to see some value of it within their lifetime so they can do something interesting with the upside. What that means is that you need to be much more stringent with how you pick ideas. And like I said, that's where my, you can hear it, fascination with where do things sit across, mythic tech versus deep tech type spectrums, and have they moved from fundamental science discovery into an engineering deliverable? We look for things using our experience of being both academic PhDs, but also operators within deep tech companies ourselves, and the speed change between academic speed and entrepreneurial speed as something that helps us gauge what are the milestones that need to be presented and roughly how long do those milestones take. And that activity is something that we do alongside the founders that we back to understand just, are they mapping to the right milestones? Do they get the right inflection? Can they raise the next round of investment? And how long is this place? How long is this piece of work? So that we don't run out of, the appropriate amount of hype for some of these breakthrough technologies.
Great. Now let's shift the focus towards the UK ecosystem. When it comes to the UK and Europe deep tech ecosystem, the UK is often described as a science superpower, but a scaling underperformer. Why do you think that gap exists?
That is very polite. So why do I think that gap exists? And I guess specifically within deep tech also, but I think it broadly exists across all asset classes. Part of that, and again, focusing on the bit that I think about, I usually think about it in terms of, I guess, something equivalent to Maslow's hierarchy of needs, right? At the very bottom, we need entrepreneurial motivation and self-belief to starting things. And like I said, most scientists don't even realize it is their job to starting companies. There is also across the UK and Europe, maybe if you compare yourselves to, I guess, the golden children. I grew up in America, so I feel biased as to which way I'm talking about at any point in time. A lower level of, it's obvious your job in life is to be an entrepreneur or start something or do something different. That's where you fundamentally have to start. And only very recently has that activation work been happening. I would say the last 5 to 6 years. It's not bad when you go, ironically, through harder times, because it forces people to be more creative and starting things. But beyond that, you need an ability to actually find capital. And finding capital, I think people often think that it needs to be local capital. I'm setting up a company in Scotland, I need Scottish capital to back this thing. It doesn't. It helps if it is, because those people usually are good advisors and can help grow the company. But quite a lot of the early stage, you just need some capital liquidity to actually exist, and you can find those things. There are good investors within the UK ecosystem. Predominantly, they shift early rather than late. But also, there needs to be sufficient quality early where there is the incentive and believability that a late stage capital deployer could make viable returns. And that's something that we've often struggled with. We've struggled at the early stage. Like I said at the beginning, there weren't very many deep tech investors because there wasn't much deep tech. Later down the line, There aren't very many large capital deployers because there isn't very much early pipeline. That is now changing. And what we're starting to see is that people are coming and raising bigger funds and deploying them central to the UK and Europe.
Right.
The bait and switch is that we do have big capital deployers in other parts of the world. And do you risk the brain drain effect of letting them jump ship and cross the Atlantic, or do you try and keep them here? And that's like a two-pronged question. On a case-by-case basis, it is in their interest to jump ship and deploy and go where the capital is. And that totally makes sense, and you can't fault anyone for doing that. Is that bad for an ecosystem-wide perspective? Yeah, 100% it is. But it only changes when you have good capital deployment. So you just need to bring that piece in first and then trust that people will stay, because they will. It's harder to book a flight to go to America and find capital. You'll do it later in the process, but also it's complementary. So we shouldn't look at it as like a negative activity. At the end, these companies will have global acquisitions. So the capital will probably not be coming from anywhere in particular. It'll be wherever those big corporates or IPOs are ultimately based.
Great. That's a really interesting way to frame it, almost like a hierarchy where ambition and motivation sit at the base. But scaling ultimately depends on how accessible the capital is and the right networks beyond just the local ecosystems. Great. Now, another follow-up question here is, like, you've mentioned that there is a strong US capital flowing into the UK companies, but less domestic conviction. What needs to change for Europe to retain and scale its own deep tech champions?
Americans know a good deal when they see one, right? The UK and Europe punch well above their weight in terms of the quality of intellectual property and ideas, and even the human capital that they have to deploy to these things. They are phenomenal. And I've spent a lot of time touring around, the bigs of the States and looking at just like, what are they doing and what lessons can we learn from it? And fundamentally, like, the quality of the IP and the quality of the individuals, absolutely on par, regardless of where you look. So really the activity is into convincing domestic capital to understand these sorts of things is that same kind of bottom of the pyramid that I was just talking about, of like, you need a culture of backing these sorts of individuals. And to do that, you need enough of them and enough good role models and enough win conditions of them to build a believable and credible story. Mm-hmm. The sad point at the moment is that I find it easier into our funds to raise capital from folk in California to deploy in the UK than I do to find folk in the UK to deploy into companies that are here alongside them. That is a cultural change as much as anything else. And that cultural change, you can't fault them for it, only comes if you start showing winners. But there is a lot of stuff happening. And I think, like, it's an activity of like making sure people wake up and see the opportunity. Because at the moment we're kind of sleeping on it.
Right. This could just be a follow-up question here. Like, compared to the US, how does the European ecosystem differ when it comes to supporting deep tech founders?
I assume the implication is kind of like compared to the US, or is it Europe versus UK?
Mm-hmm. Yeah, I mean, see, the local investors, European investors,
mm-hmm.
US investors, they do back their deep tech founders, and then European investors are slightly behind. So when it comes to supporting deep tech founders,
mm-hmm.
right? So how do you see that gap?
So I think, like, oftentimes it's actually easy to over-index on how well the American market is allocating capital into deep tech.
Mm-hmm.
It is better at allocating capital.
Got it.
Actually, when I go talk to funds over there, there are some real blind spots that I think they've learned from deploying in traditional tech funds that they are applying into deep tech and not seeing the same return, KPI, growth, pre-money valuation, whatever it might be. So there are just some fundamental lessons to learn about the asset class that are just different, but that doesn't stop the fact that they are just rapid capital deployers. The thing that I found most different about the kind of American market versus UK European market is that American market is, they trust founders to get on with the job. And here, for better or for worse, we have a lot of slow gatekeeping in terms of like how we allocate things. So we have fantastic grant programs that remove some of the risk, the capital risk associated to getting companies started. But the logistical process to actually access one of those grants is incredibly tedious, and then deploy it is even worse. And you have a success rate of like 5% of the actual cohort. So tons of people are writing these applications. Very few people are getting them. And it's both holding up their progress in terms of otherwise they'd just be out there raising capital some other way, not hoping that there would be, you know, something closer, easier, non-dilutive, yes, to home that kind of looks like an easier option for them. But I think like that's kind of an overall, it's like it's a net good, it's a net bad. It's good to be supporting these sorts of things. They are high risk at the early stage. Fundamentally, does it sometimes weaken the speed at which they're looking to progress and the capital that they're looking to raise from just the private market? Yes, absolutely. And I think that's kind of a shame.
Got it. Now, let's talk about spin-outs and university system. There's a very interesting question that I wanted to ask you. There's always an ongoing debate about equity splits between universities and founders. What is the right balance in your view?
Okay. So this has been a large part of my career. I don't really describe it online very often because it gets me in trouble. But the whole goal of Spin Up Science was to improve the dynamic. I started Spin Up Science because more often than not, I would argue even through no fault of a universities, they were crippling companies from day zero and founders from day zero without quite appreciating it. And specifically what that was, as you go to access the intellectual property for a company, the idea that you have created that the university owns, you are asked for an equity exchange to access that intellectual property. Back when we started work, that very typically was like north of 50%, sometimes up to 66, sometimes up to 75% of a company will be owned by a university, the remaining amount owned by the founders or the people actually running the thing, which we thought was crazy. That has come down. That has come down through a lot of just what I refer to as gentle guerrilla warfare and education of helping people have conversations and facilitating them. And that's both the university side and founder side. So we've driven that number down to much more reasonable at the moment. I mean, the market rate is too high, but the equivalent market rate at the moment is more like 10 to 20% is what a university will take. The founders get 80%. You care about that number because you want the founders owning majority share by Series A. So north of 50%. A couple rounds of dilution, 20% dilution per round means they need to own about 80% minimum at day zero. Really what you want is universities south of 10%.
Got it.
Because then there's just space on the cap table, right? For other advisors, for co-founders they may bring in to support, for other people, and there's just more space. It also really should be a flipped model entirely of the reason you join Apple and make the iPhone is because you get a great paycheck and because it's interesting work. But at the end of it, you have no expectation that the piece of the iPhone that you developed is yours. That would be nonsense. That isn't true within an academic setting. You are, as a lead academic, literally the most sophisticated person in the world in the area of study that you are doing.
Right.
You direct your course of research, and you, like an entrepreneur, raise money to be allowed to go conduct it. The university doesn't give you a research pot. You go apply to some central grant agency external to a university in order to access this money. Right. If you win, which is hard, you bring that money into the university, and the university takes approximately 50%.
True that.
To run the university and the administrative processes and keep the building, you know, all of those sorts of things. And you get to do research with the remaining 50%.
All right.
There isn't anyone telling you what to do. And there isn't, beyond HR and administrative support and lab technicians and things like that, much direction as to like what to build or how to build it. You are the discoverer.
Right.
So at the end of the day, after that discovery process works, it kind of should sit within your ownership as the academic, because you've paid your tax, you've paid your lump of flesh. It was 50% of the money to do the research activity. And then I think what it means is that if an academic owns the intellectual property, the university should then be invited into the company, because I want to reward university because they are the ecosystem that starts these sorts of things. They're super important.
Right.
But it's more about what can I offer into this entity versus what do I own and what does it owe me? That's like a broken backwards way of kind of thinking about this process. So if it's going to offer lab support, if it's going to offer consumables, amazing. Take some equity position in the company. Right. Same as a venture builder, right? And I think that's a healthier way to frame this whole thing.
Great. It's a very crucial point. If the cap table becomes too constrained early on, it can actually limit companies' ability to raise future capital and scale effectively, I would say. Also, and universities obviously play a critical role in creating the IP, but the structure has to leave room for the company to grow. Great. Now, let's talk about the LP's side of it in the deep tech ecosystem. How should an LP think differently about deep tech investing compared to traditional software VC investing?
Yeah, that's a great question. So a lot of LPs, what I'm finding is that I'm doing quite a lot of education work as to just what is deep tech and what are the rule sets by which it is governed and how does it differentiate itself from a traditional tech fund. I find a lot of people are reluctant because they think it is inherently significantly more capital intensive and significantly longer in timeline.
Mm-hmm.
Like I said, my earlier point is I define deep tech as things that are backable and deliverable across venture timelines. So I'm looking for it to fit into fund lifetime, as like a just definitional part of the asset class, because otherwise why are we even thinking about the asset class like that? What you also find is that, yes, they are more capital intensive, but they're more capital intensive typically in a different way, where you can pour an extra 5 to 10 million into a software company. And what does that enable you to do? You hire a bunch more software folk. Awesome. The tech development just fundamentally runs faster. Oftentimes, you can't actually do that within a science company, a deep tech company, and expect that the science will go any faster. Oftentimes, you're hiring literally the best people in the world, and those literal best people in the world at doing that science were the people that discovered it and sit in the academic group. So you can bring in some support around them, but actually moving the science forward significantly faster. I mean, a lot of it is like clinical trial based or just discovery based. So it has some slower timeframes by which you can actually ramp through the technology stack. What that means is that in the early stages, because you aren't taking as big steps in de-risking the tech, like it might take 18 months to go from TRL 3 to TRL 4, whereas if it takes you that long in a software company, you're doing something totally wrong, right? It means that the pre-money uplifts in those early stages just inherently are lower. And where the real ramping happens is more like Series A and beyond.
Right.
So a lot of LPs get concerned when they look at pre-seed seed investors and are like, oh, hang on, like this thing only 2.5, 3x, 4x between pre-seed and seed. That's like fundamental to the asset class. That's exactly what the thing should be doing. What you're interested in doing is getting in before Series A, because suddenly you're holding a fusion company, or you're holding a nuclear fission company, or you're holding a quantum computer company, and that suddenly goes from quite a cheap pre-money valuation, like south of 20, to potentially many hundreds over like the next 18 to 36 months. So they're kind of lumpy in a different way. And I think, like I said, just the community of investors in deep tech and the LPs are learning the lessons by which these kind of assets are actually evolved into the market.
Great. Now that's a really important shift, because deep tech isn't just another category within venture. It comes with fundamentally different timelines, risk profiles, and paths to value creation. And as you said, a big part of the job is actually, I think, educating LPs around that reality. Great. Now, moving on to the final question for today's podcast. If we fast forward 10 years, which scientific breakthroughs today will have the biggest real-world impact?
So I mean, I am biased. I won't say why. I'm particularly interested in energy plays at the moment.
Mm-hmm. Energy.
And that isn't necessarily because, we are decarbonizing and moving away from kind of old ways of energy production. That is because I think we're like finally getting our level of scientific discovery process in line with just actually how do we deploy these systems and make the economics work.
Right.
I always talk about, and point to things like just the challenge of something like nuclear, like large nuclear into small modular reactors, into, man, these things aren't quite working, like the unit economics still doesn't work time and time again, into advanced nuclear reactors. And what we are starting to learn is that what was a scientific discovery process needs to just be inherently wrapped in unit economics. And that's really interesting. We're getting way better at doing those sorts of things. And that's that blue skies research, but with a more specific lens as to where it needs to turn out and what good looks like. I think that's really interesting at the moment. And what we're seeing is a ton of innovation that looks orders of magnitude better, more efficient, lower cost of electricity than what we're seeing. And that matters because of all the reasons that you'd expect it to matter, big AI data centers and all of that sort of stuff. That's where I'm particularly bullish at the moment. That's what I think is most interesting.
Great. I second with you on that. Now, this has been a fascinating conversation. What really stands out is that deep tech is not just about breakthrough science. It's about discipline of turning that science into something investable, scalable, and ultimately impactful. From thinking about IP and commercialization early to navigating long timelines through milestone mapping to even reshaping how LPs and universities approach the ecosystem, it's clear that building in the space requires a very different mindset. And perhaps most importantly, it highlights that while the UK and Europe have incredible scientific depth, unlocking that into real global venture scalable companies comes down to aligning incentives, capital, and ambition in the right way. Dr. Ben, thank you so much for sharing your perspective. This was incredibly insightful. I'm sure the audience are going to get immensely benefited. You've shared a very interesting perspective and great insights on the deep tech ecosystem. Thank you so much for joining us today.
Awesome. Thanks so much for having me.